Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze this WASH basin for its thermal analysis. We have already made the model of this sort, so you can just go back to the video and refer it for making of the geometry, because here I am going to directly import the geometry. So we will start by double clicking on steady state thermal. I'll first go to engineering data. Like in the previous video, when we analyzed for static structural analysis of the wash basin, we had chosen the material as ceramic. So I will add the material ceramic again for this analysis. Now when you go for thermal analysis, you don't have to give the properties which we gave for static structural analysis. Here the most important property is isotropic thermal conductivity. So that's the important value here. So we will go back to this table. You can refer this website for this detail. And here if you figure out the thermal property, the maximum used temperature in air in no load condition is 1750 degrees Celsius. This is something very important to note, because this is the maximum temperature that your ceramic material can bear, and only after this temperature your ceramic material may start melting or decomposing. So this is something important. And thermal conductivity value is also given. It is 35 watt per meter degree Celsius or Kelvin at room temperature, that is 22 degrees Celsius. So we will add the value as 35 at 22 degrees Celsius. So this is complete. We'll go back to project and update project. I'll go to geometry and right click. I'll import the geometry of the wash basin. Next I'll go to model and double click on it. This is the model. I'll first go to geometry and change the material to ceramic. Next I'll go to mesh and change the sizing to fine and update. You can see here tetrahedron mesh has been created. Next I'll go to steady state thermal and I'll right click and insert temperature. So this wash basin could be subjected to a hot fluid. So I will press Ctrl and select all the inner surfaces and give this value as say 100 degrees Celsius. See, some hot water falls on this wash basin and we want to check for it. Also there will be convection on the outer surfaces. So I will insert convection on the outer surfaces by pressing the control button. The film coefficient is approximately 0.5 to 1000 watt per meter square degree Celsius. So let me give the value as 10. Next I'll go to solution and insert thermal temperature. Also I will insert total heat flux. I will also insert directional heat flux. I'll go to solution now and solve. We can check the temperature here. You can see the temperature distribution over the body. It's only in the inner surface that the temperature is 100, and on the outer surfaces you can see that the temperature is 99.76. That is, the ceramic material is not a very good transmitter of heat. So on the outer surface you won't feel the hot temperature which is inside. You can see here the total heat flux value is 943.84 watt per meter square. That is the maximum value here. And on the outer surface where I can see this yellow color, this value is ranging from 734 to 839 in this zone. And on the other zones you can see the color from here, and you can just tally the color and the values. Next we will see the directional heat flux. The maximum value is 923.52 watt per meter square, and this is along the x-axis that I have taken. You can take the value similarly along the y and the z axis also and check the values. So this is how the directional heat flux along the x-axis looks like. We can simply add for y and z also, and just go for solving it again. So you will get this value along the y-axis 911.77 watt per meter square, and the directional heat flux along the z-axis is 324.56 watt per meter square. So you can see that along the three axes the value is different. Maximum value changes from 923 along the x-axis to 911.77 along the y-axis, and along the z-axis the value is 324.56, and accordingly you can see here the heat transfer rate which is taking place over the body. So with this I end the session. I hope you have understood how to analyze a wash basin for its thermal analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.